Hello, this is MEI Further Maths Core Pure. We're in the third Matrices section and on the first video, which is an introduction to inverse matrices. You can watch the video straight through, but you will probably find it helpful sometimes to pause the video and try things out for yourself before continuing to watch. OK, pause the video for a moment now while you try this for yourself. You'll need to form some simultaneous equations to solve. OK, if we do this multiplication, we get this matrix. 2a plus 3c, 2b plus 3d, a plus 4c, b plus 4d. And we know that that has to be equal to the matrix 1, 0, 0, 1. From this, we can get some simultaneous equations. We know that 2a plus 3c must be equal to 1, a plus 4c must be equal to 0, 2b plus 3d must be equal to 0, and b plus 4a must be equal to 0. You can see that these fall into two pairs, each of which we can solve simultaneously. That will give us the results. A is 4/5, B is minus 3/5, C is minus 1/5, and D is 2/5, which gives us this matrix. Check for yourself that multiplying the matrix 2, 1, 3, 4 by this one does give you the matrix 1, 0, 0, 1. You'll also find that if you do the multiplication the other way round, you get the same matrix, just in this special case. Here's some notation and terminology about what we're doing. If our original matrix is called T, then our new matrix is called the inverse of T, and it's written T to the minus 1. So we have this. So here we have that T inverse is the same as T inverse T in this special case, and it equals 1, 0, 0, 1. This implies that we get a unique inverse. We don't have different inverses for left and right multiplying. And it also means that only square matrices have inverses. We can do the same sort of thing with 3 by 3 matrices. In this case, remember that our identity matrix is 1, 0, 0, 0, 1, 0, 0, 0, 1. So that if we're told that A inverse is this matrix here, we know that A multiplied by A inverse is equal to that identity matrix. So let's work out A inverse. OK, we get 10 minus 1 is 9 plus 2p as the first entry. 10 plus 2 is 12 plus 3p as the next one. 5 plus 3 is 8 plus 2p as the bottom one there. And for the middle column, we'll get minus 16 plus 2 plus 14, which thankfully is 0. And then minus 16 minus 4 is 20 plus 21 is 1. And minus 8 minus 6 is 14 plus 14 is 0. So that column is correct. And then 14 minus q minus 12 gives us 2 minus q. 14 plus 2q minus 18 is minus 4 plus 2q, and 7 plus 3q minus 12 is minus 5 plus 3q. Taking the simplest looking cells first, we can see that 2 minus q must be equal to 0, and therefore q is 2. If we look at the next cell down, we can see that that gives us 0, and the bottom one gives us 1 as we needed. And then I think this is probably the easiest one to do. That's got to be 0 as well. 8 plus 2p equals 0 gives us that p is minus 4, and that gives us 12 minus 12 is 0 there, and 9 minus 8 is 1 there, which is correct. So we know that P is minus 4 and Q is equal to 2. That's the end of this short introduction to inverse matrices. In the following videos, we'll be looking at efficient methods of finding inverses.